Okay, this is section 6.3, day 3, and we're going to continue our work with vectors today. We're going to do some application problems, so using this in the real world. Of course, you're probably not going to actually do this real world math, but at least these are examples as to where it would be used. The first one says, find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle 30 degrees below the horizon. And then I say as shown, but I probably forgot the picture for you, so we're going to draw this picture in here. Here's the horizon. The plane is going downward at a 30-degree angle. So that's 30 degrees right there. And the plane's going 100 miles per hour. So that 100 miles per hour is representing our magnitude, our speed, our velocity. And then our angle of 30 degrees below the horizon. It's not it's a 30-degree angle, but the measure of the angle is not 30, and that's a little confusing. But if I were to measure the angle going in this direction, that's actually either a 330-degree angle, so measuring it this way, or you could say it's negative 30, but it's not just a straight 30 degrees. So we are supposed to find component form for this vector, and component form has that bent parenthesis look to it. And in order for us to figure that out, we really only have two things to work with here, which is one is magnitude, our 100, and then our theta, which is 30. So we're working with a magnitude, a distance, a length, or an r, and then we're working with an angle, or a theta. So using kind of our knowledge from our polar unit, our polar coordinates unit, we remember how to convert using an r and a theta into more of an xy coordinate, or more into a component form. So we're going to do r cosine theta, and then r sine theta. So that will combine both my magnitude and my angle to give me what the vector is doing, kind of an over and down look at this plane. So using my r with 100, and then cosine of 30 degrees, sorry, negative 30, my bad. And then 100 sine negative 30. And all I have to do is just type that in your calculator. You're going to get two different numbers. Hold on, I got to get the decimal for that first one. So typing in 100 cosine negative 30 gives me an 86.60, and then 100 sine negative 30 gives me a negative 50. And so I'm just going to look and make sure that this matches my picture. This is kind of the X and the Y movement. So does it make sense that from the origin my plane went over 86 and then down 50? And that does at least match my picture. I'm going a positive move and then a negative move. So using that same idea, we're going to move into this second problem here. It's got a lot of space. We're going to need some room. This one's talking about an airplane, again, traveling at a speed of 500 miles per hour with an angle of 120. So now we're talking about, draw a little picture here. So my airplane going at 120 degrees, probably right about there, and a speed of 500 miles per hour, and I'm going to make it about that long. So this is my airplane right here. At some point in the flight, the plane encounters a wind blowing with a velocity of 70, so much shorter or less magnitude of the plane's flight, and then an angle of 45. So at the end of my vector, we want to put another one, smaller. So if this is 500, we want to only do 70, so it's going to be kind of small, and it's got to be at a 45-degree angle, which is right about here. So I'm going to make about that be 70, and that'll be my wind vector. So what we're looking at in the end is where is it pushing our plane, and that's called the resultant. And we've done that before when we're talking about adding two vectors together. So when we have our airplane and our wind, it's going to move our airplane over a little bit, make it a little bit longer, so it's going to gain a little bit of speed, but it's going to mainly move it over and adjust its course, and that is my resultant vector. So now we got to do the math to match our picture. Using the same thing we did above, I'm going to have a vector for my airplane. So I'm going to use 500 cosine 120 and 500 sine 120. And I'm going to have a vector for my wind. 70 cosine 45 and 70 sine 45. I'm going to type these in my calculator real quick, find out what they are as decimals so that we can kind of move forward with our information and put them together. Because we're going to be talking about our plane and our wind meeting. And although this isn't a tailwind per se. Sorry, 433.01. This isn't a tailwind from the airplane. It's not coming behind and just pushing the airplane. It is having an effect on the airplane. So we need to put those two vectors together, essentially adding them. And we're going to figure out what is that wind doing to the airplane overall? How much is it moving it off course? How much do we need to course correct to put us back on the right flight path? And 49.49. I'm crudely rounding these, because I want it to have a little bit of a decimal so that we can see what's going to happen. So I've got this negative 250. I'm going to add it. We're putting these two vectors together. That's an equal sign. It's not very clear. And then we're going to take our x's and put them together. What we're coming up with is our resultant vector. We're figuring out where will the plane end up. What's the result? So our negative 250 plus our 49 ends us at about a negative 200.5. Which makes sense because we're definitely going left, so that's negative. And then 433 plus the 49 gives me a, whoops, hold on, I made a mistake. That should be a plus. Nope, hold on. 433.01, and add our 49 in there. We end up at a 482.5. And so this is saying, do you go left 200? Sure. And then up 482. So am I going up about twice as far as I went over, and that's about accurate. So as far as I'm going over, I'm going up a lot farther. So this is our resulting vector. That is not the speed or direction of my airplane. So in order to find the speed, which is the velocity, which is the magnitude, we need to do our magnitude formula. And when we have it in component form, all we really need to do is square these two guys and then add them up. So 200.5 squared and 482.5 squared. And when I get done doing that, I end up with a 522.5, and this is miles per hour. So that totally makes sense. Our plane was going 500. We could see, compared the lines, that this one's a little bit longer, so it's picking up a little bit of speed, and that's about 22 miles per hour is what it's picking up. We also need to find out our angle, or our direction angle. What angle is the plane flying at? And so we're going to do our tan inverse trick to finding angles. Y over x, so 482 over negative 200. And when you do that in your calculator, you actually get, hold on, I got to do that one real quick, 42.5 over negative 200. And you end up with negative 67.43. And we talked last chapter about how you have to really pay attention to your vector and then where your angle lands you. So negative 67 degrees would actually put us in quadrant 4, which is not where our airplane is. We're in quadrant 2. So in order to move from a 4 to a 2, we just need to add 180 to that. So when I take that angle and add 180, I end up at 112.6 degrees, which, based on my picture, makes sense too, because I got pushed to the right. So I should definitely be less than 120, which is what we were at. And now we're at 112, which makes sense because it's just a little bit less. So my resulting speed, 522, and my resulting direction of the plane, 112.6 degrees.